Good morning. Today we will discuss a few questions related to tangents and normals. First question is the equation of the curve is y is equal to 5 minus 3x minus 2x square. Show that the equation of the normal to the curve at the point minus 2, 3 is x plus 5y is equal to 13. So here equation of a curve is given. We have to find the equation of the normal. We have to show that equation of the normal is x plus 5y is equal to 13 at the point minus 2, 3. Okay. So let's consider the curve y is equal to 5 minus 3x minus 2x square, and it has a point minus 2, 3. Let's take minus 2, 3 as this point. Okay, so we need to find the equation of the normal through this point. But before finding the equation of the normal, let's draw a tangent through that point with a gradient m1 so that its normal is perpendicular to the tangent with a gradient of m2. And as we discussed earlier, as they are perpendicular, m1 multiplied by m2 is equal to minus 1. This is a concept we are using here also, but we require m1. What is m1? m1 is the gradient of the tangent. So we need to find the gradient of the tangent. For that, let's take the equation, because we know that gradient of the tangent is same as derivative of the curve at the certain point of x. So let's find the derivative of the curve. The curve is y is equal to 5 minus 3x minus 2x square. So let's find the derivative of this. We get dy by dx is equal to 0 minus 3 of 1 minus 2 of 2x. That's equal to minus 3 minus 4x. So at the point of contact, that means at the point x is equal to minus 2, we get gradient of tangent. We never get gradient of normal directly. We get gradient of tangent. Let's denote it as m1 is dy by dx at x is equal to minus 2, which is minus 3 minus 4 of minus 2. That is equal to minus 3 plus 8, which is 5. So the gradient of the tangent is 5. That means m1 is 5. Hence gradient of normal is minus 1 by m1. By using the concept, m1 multiplied by m2 is equal to minus 1. So we get minus 1 by 5 is the gradient of the normal. So now for normal we have gradient as minus 1 by 5, and the point of contact is minus 2, 3. Therefore, equation of normal is y minus y1 is equal to m of x minus x1. So when we replace it, we get y minus 3 is equal to minus 1 by 5 of x minus minus 2, which implies when we cross multiply this 5 to left hand side, we get y minus 3 multiplied by 5 is equal to minus 1 of x plus 2. Minus into minus plus. That implies 5y minus 15 is equal to minus x minus 2. Now we have to rearrange the terms as per our question. We get, when you take this minus x here and minus 15 to right side, we get 5y plus x is equal to minus 2 plus 15, or x plus 5y is equal to 13. hence shown. Hence shown. This is the first part of the question. So let's consider both the equations. Y is equal to 5 minus 3x minus 2x square is the equation of the curve, and x plus 5y is equal to 13 is the equation of the normal. Okay, so this is a quadratic equation and this is a linear equation. So here we have two simultaneous equations of one is quadratic and the other is linear. Now our task is to solve these two equations. Okay, so for that I'm taking this equation x plus 5y equals 13. So now I replace this y value with this. So it becomes x plus 5 of 5 minus 3x minus 2x square is equal to 13. So it becomes x plus 25 minus 15x minus 10x squared is equal to 13. It becomes, so let's simplify this by adding or subtracting the like terms. Before that, let's take this minus 10x squared first. So minus 10x squared, we get minus 15 plus x is minus 14x, and when we take this 13 here, we get 25 minus 13 as plus 12 is equal to 0. So here we have a quadratic equation. If we solve this quadratic equation, we get the x coordinates of the meeting points of, if we solve, we get the x coordinates of these two. Okay, so let's solve that one. So to solve this quadratic equation, I'm using quadratic formula, which is x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay, where a is minus 10, b is minus 14, and c is 12. So let's solve this equation. We get minus 14, that is minus of minus 14 minus b, plus or minus under the root b square, that is minus 14 squared, minus 4ac, 4 times minus 10 into 12 divided by 2a, 2 times minus 10. Yes, so just go on with this calculation. We get two values for x, which is minus 2 and 0.6. Minus 2 and 0.6. That is nothing but the x coordinates. And already you know minus 2 is one of the x coordinates in your question. So the x coordinate of the next meeting point is 0.6. Now we need to calculate the y coordinate. At x is equal to 0.6, what happens to y? You can use y is equal to 5 minus 3x minus 2x squared, or the equation of the normal. Any one of these equations can be used. Either you can substitute x is equal to 0.6 in this quadratic equation, or you can substitute in x plus 5y is equal to 13. Anyway, I am substituting in this. Let's see what we get. We get y is equal to 5 minus 3 of 0.6 minus 2 of 0.6 the whole square. Do this calculation, we get the answer as 2.48. Next question. The normal to the curve y is equal to 6 divided by square root of x minus 2 at the point 3, 6 meet x-axis at P and y-axis at Q. Find the midpoint of PQ. So what is meant by this question? So just when we analyze the question, we understand there is a curve y is equal to 6 divided by under the root x minus 2. It has a normal at the point 3, 6. This normal meets x-axis. When we extend the normal, it meets x-axis at a point and y-axis at another point. So it meets x-axis at P and y-axis at Q. We have to find the midpoint of PQ. That is the question. So let's make the corresponding figure of this question. So in figure, the normal meets the curve at the point 3, 6 and it meets x-axis at a point and y-axis at another point. We need to find the coordinates of these 2 points. And on x-axis the value of y is 0. On x-axis y is 0. So the point P can be assumed as x0. And on y-axis x is 0. So the point Q can be assumed as 0y. Okay. So now let's assume P as x0 and Q as 0y. Okay. So our next step is to find the equation of the normal. So let's find the equation of the normal using the curve y is equal to 6 by root x minus 2. If you derive it, before that let's make it in standard form. Now derive it, we get dy by dx is equal to, use chain rule here, just use chain rule here for this. I'm using it directly. It is 6 times minus 1 by 2 of x minus 2 raised to minus 1 by 2 minus 1 into derivative of x is 1. So you have to use chain rule, just I am doing directly. So we get it as minus 3 of x minus 2 the whole raised to minus 3 by 2. Minus 1 by 2 minus 1 is minus 3 by 2. So we get it as minus 3 divided by x minus 2 the whole raised to minus 3 by 2 as plus 3 by 2 as dy by dx. So this is our dy by dx. Okay, now we have to find the gradient of the tangent. To calculate the gradient of the tangent at x equals 3, gradient of tangent is, just replace x equal to 3, we get minus 3 divided by 3 minus 2 the whole raised to 3 by 2. Yes, that's equal to minus 3 divided by 3 minus 2 is 1. 1 raised to any power is 1. So we get m1 is minus 3. Now, therefore, gradient of the normal is minus 1 by m1, which is equal to minus 1 by minus 3, that is 1 by 3. So we got gradient of the normal here. Now with the help of this gradient and this point of contact, we have to find the equation of normal. So here you can find the equation of the normal is already calculated. M is equal to 1 by 3 and the point of contact is 3 by 6. We are finding the equation of the normal using the formula y minus y1 is equal to m of x minus x1. Substitute the values and rearrange the terms. We get x minus 3y is equal to minus 15 as the equation of normal. Okay, now our next step is to calculate x and y. So to find x and y, that means to find the point P. To find point P, we required x coordinate, and for Q, we required y coordinate. So let's find the point P first. That means the intersecting point of x-axis and the normal. That point we are going to find out now. So to find p x0, substitute y equal to 0 in this equation. Substitute y is equal to 0 in this equation. We get x minus 3 times 0 is equal to minus 15, or x is equal to minus 15. So we get the point P is minus 15, 0. That means the normal meets x-axis at P minus 15, 0. We get the result there. Similarly, we can calculate Q. So to find Q, 0y, put x is equal to 0 in the equation, x minus 3y is equal to minus 15. So it becomes 0 minus 3y is equal to minus 15. Do the calculation, we get y is equal to 5. Therefore, the point Q is 0, 5. So here we get both the answers. Another question. The normal to the curve y is equal to 2x square plus kx minus 3 at the point 3 minus 6 is parallel to the line x plus 5y is equal to 10. Find the value of k. So to find the value of k, it is a very simple process. So we have the equation of the curve and a point on the curve. Just do substitution of this point to this equation, we get the value of k. So it's very simple. We get y is equal to 2x square plus kx minus 3 at 3 minus 6. We get minus 6 is equal to 2x square. That means x is replaced as 3. 2 into 3 square plus k into 3 minus 3. This minus 6 is equal to 18 plus 3k minus 3. Minus 6 is equal to 15 plus 3k, or 3k is equal to minus 21. It implies k is equal to minus 7. We get the value of k in a simple way. So the equation of the curve is y is equal to 2x square minus 7x minus 3, as k is minus 7. Okay. Part B is find the coordinates of the point where the normal meets the curve again. So this question is also related to normal. We have to find the coordinates of the point where the normal meets again. So already normal meets at a point 3 minus 6. Okay, now we have to find out this point also. We have done a similar type of question in the same class, but here a little change you can find. Okay, so what is given? The normal to the curve y is equal to 2x square plus kx minus 3 at the point 3 minus 6 is parallel to the line x plus 5y is equal to 10. So what they have mentioned is the normal is parallel to another line. Suppose this is normal. This normal is parallel to another line. So these two lines are parallel. This line is x plus 5y is equal to 10. So we can use the concept, as the line is parallel to the normal. What about their gradients? Yes, they have the same gradient. So as x plus 5y is equal to 10 is parallel to normal, what you can find out? Their gradients are same. They have the same gradients. So if you find the gradient of x plus 5y is equal to 10, that will be same as that of normal. Yes. So for that, let's find the gradient of x plus 5y is equal to 10. So x plus 5y is equal to 10. It implies 5y is minus x plus 10, or y is minus 1 by 5x plus 10 by 5. Just I converted it in the form of y is equal to mx plus c. Y is equal to mx plus c. So what is the value of m here? Minus 1 by 5. So m is minus 1 by 5. That will be same as the gradient of normal. Gradient of normal. So now it's very simple. We got the gradient of normal and the point of contact. So our next task is to find the equation of normal. So when we find the equation of normal with the gradient minus 1 by 5 and the point of contact 3 minus 6, we get equation of normal as x plus 5y is equal to minus 27. You just do the calculation and get the equation of normal here. Now we are going to find the next point, next intersecting point of curve and the normal. The second intersecting point of curve and the normal. Okay, so for that, let's take the equation of curve, which is y is equal to 2x square minus 7x minus 3, because k is minus 7, and the normal is x plus 5y is equal to minus 27. So here you have a quadratic equation and a linear equation. That means these two are simultaneous quadratic and linear equations. So to solve this one, first we have to make it as a single equation. For that, I am taking this value, x plus 5y is equal to minus 27. Y can be replaced with this value. So we get x plus 5 of 2x square minus 7x minus 3 is equal to minus 27. There we get x plus 10x square minus 35x minus 15 is equal to minus 27. Or when you simplify it, we get 10x square minus 34x plus 12 is equal to 0. So here we get a quadratic equation. Now solve this quadratic equation using the formula minus b plus or minus square root of b square minus 4ac by 2a. Okay. So when you solve this quadratic equation by using minus b plus or minus square root of b square minus 4ac by 2a, we get two solutions which are 0.4 and 3, where 3 is the given value, coordinate of x. So the required coordinate of x is 0.4. Now substitute this x either in the equation of curve or the equation of normal. Substitute x is equal to 0.4 in the equation of curve or equation of normal, but not in this equation. Don't substitute in this equation, because this is not the line which passes through the curve. Okay, so substitute x is equal to 0.4 in any one of these equations, because this point is formed by the joining of these two equations, curve and straight line. So when you substitute in this, we get 0.4 plus 5y is equal to minus 27, and solve it, we get the value of x as, sorry, y as minus 5.48, minus 5.48. That means the next intersection point is 0.4 minus 5.48 as answer. Okay, thank you.